Hi, good afternoon for those of you who are joining me live at InfoSec and for those of you who are listening in on the live stream. My name is Kev Breen, I'm the Director of Cyber Threat Research at Immersive Labs. And this afternoon we're going to go through a little bit of an exercise looking at some application security stuff. So this morning we looked at the crisis simulation, we looked at how you can respond and how you make decisions. What we're going to do now is we're going to take a look and see how you actually go and look at those applications, how you can make those determinations. What we're going to look at specifically today is we're going to look at application security and how you fix vulnerable apps. So it's no surprise that applications come with vulnerabilities. I don't think anybody in the world can say they've ever shipped an application that's been 100% perfect and has never had a vulnerability. So they're going to happen, and what we're looking at doing is how can you engage with your developers, give them the tools and the techniques they need in order to build secure applications. So the way we do this, we have what we call labs, and the idea is we build a deliberately vulnerable application. We give the application to the developer, we give them the source code, we give them a live view, and we give them some information on how this can be exploited and the kind of impact it can have. From there, it's up to the developer to actually go and fix it. So we've got a couple of different languages we can focus at. I'm going to start with some nice easy things. I'm going to look at some Java. So Java's used a lot to build full stack applications as well as some desktop apps. And the same kind of vulnerabilities can exist whether you're looking at web applications, desktop applications, or even into the mobile world as well. So we've got a range of things here. These ones are mapped mostly to OWASP, but we cover a wide range of CWE vulnerabilities. So whether it's business logic flaws, whether it's a vulnerable library, or whether it's some kind of vulnerability like command injection, we cover a full range. So I'm going to jump into one of my favorites. I'm a big fan of XSS, mainly because it's the easiest thing to find if you're doing bug hunting. So it's just nice, quick, and easy. So what we're going to learn is we're going to learn what a cross-site scripting vulnerability is, how it applies to Java and Java web-based applications, but more importantly, what I'm actually going to do is I'm going to fix the vulnerability, and we're going to do all of that live. So I'm going to start at my lab. Now what we're doing here is we're spinning up an entire virtual machine with this full stack, individual to each user, so you don't have to worry about people interrupting each other. Everybody gets their own private environment. So, like I said, this one's cross-site scripting vulnerability, so we can see a little bit of information on what cross-site scripting is, how they kind of find themselves in code. Sometimes it's a vulnerability, sometimes it's developers who maybe don't understand exactly how code can pass through from the end user all the way through to the application. So we give some examples of how they can be introduced, and more importantly, how you can fix them, how you can remediate them. How it all works, we like to look at the impact. So it's fine to say that you have a cross-site scripting vulnerability or a SQL injection vulnerability. It doesn't really mean anything to a developer, you're just saying words to them if they don't understand the security context behind them. So what we're trying to do is bridge those gaps between your security teams and your application developers. We talk about shifting security left. And from Immersive Labs, we shift it as far left as you can possibly go, all the way to the human that's actually writing the code. So SAS scanners, they do have a place and they're vital, but actually they're too far down the chain. What you want is you want your developers to understand the risks that these vulnerabilities can have and therefore try and fix them before they even make it into your source code. We talk about remediation. Like, cross-site scripting inevitably is all about input validation. So it's taking untrusted content from a user and then it's rendering that inside the browser. And if you don't understand how that can be weaponized, then this is what we're going to show you. So from there, we also look at real-world examples. It's really easy to say it's cross-site scripting vulnerability, and we talk about how does this actually affect me, what are the risks? How can my organization be affected if I have these kind of vulnerabilities in there? So we give you examples, and in this case, Tweetdeck. Tweetdeck, before it was bought by Twitter, was an application and it managed your Twitter accounts for you. Turns out that the developers who put this together had a cross-site scripting vulnerability in there. Now, due to the way that Twitter works, this was actually a self-replicating cross-site scripting vulnerability. So the person who discovered this didn't do this under the guise of responsible disclosure, and in fact just tweeted it as a, hey, look, you are vulnerable. And in, like I said there, in 2 minutes, 38,000 retweets, each one of those self-replicating. For those of you who have been in this industry for a while, if you remember Sammy Kamkar and the MySpace worm, this is exactly the same thing, except this is on something like Twitter and TweetDeck. So vulnerabilities from like 2012, 2013 still exist in applications today. And again, they can have a big impact. Cross-site scripting, usually you get a pop-up saying XSS, that's how it gets reported to you. But these can be used to steal credentials, to steal access tokens, and in the worst case, to do things like cross-site request forgery attacks. So XSS opens up this whole breadth of vulnerabilities that can be extended. So like I said, we walk you through like what it is and some real-world examples. So this is my demo application, and here you can see I've got a simple forum, I've got this login page. Like I said, this is deliberately vulnerable. So if we jump into the demo real quick, the first thing we're going to show you is how do you exploit this. A developer needs to understand how an attacker would exploit this in order to be able to go and fix it and to understand that. So the first thing we do is we show them the impact, the kind of things the attacker doing. In a Cyber Pro, when we talk about red team versus blue team, it's a very similar thing. Your defensive teams naturally get better if they understand how the attackers work. So in this instance, we can see here, this is the payload we're going to get in. So I'm just going to copy this. We're not expecting your developers to be red team professionals, so we're going to walk them through these steps. Your developers need to focus on writing secure code, not compromising it, so we don't expect them. Interesting and useful to have the knowledge, but we don't need them to do that. So if we go next, run this exploit, and you can see there I've got my XSS pop-up. That's bad. So we've now demonstrated how the vulnerability can be exploited. The developer understands now what that kind of flow from user input through to compromise looks like. So complete that. So what we do now is we go over to the code editor. And these two are linked. So this code editor is showing the live code that's actually running in this preview application. So if we look through here, if we go back to our briefing panel, we can see that these kinds of vulnerabilities are usually included when we're echoing input from the user without sanitizing it in some kind of way. So if I go back to my code, if I look down here, I can see the item title. Now, if you remember from the demo where we watched the vulnerability, it was that title field we put in that triggered our XSS. And as we can see here, this one isn't being sanitized in any way. So when the user clicks save, that's stored in the database, and then from the database, it's just rendered straight into the page. So the attacker can pretty much put whatever they want. So there's a few ways we can fix this. The one we're going to look at here is using the C out tag. So we're looking at JSP pages rather than, JSTL. And most libraries, most common libraries, whether you're working with Java or whether you're working with other applications, they usually have some kind of framework to enable you to work with this. In this instance, we provide this C out tag, which is going to do our sanitization for us. So what I'm going to dump here, I'm just going to cheat just a little bit and copy and paste. So if I grab that one, copy that, go over to my code editor, find my line, and I'm just going to paste that in. And this one needs to be item.title. So if I put item.title in here and remove the original, so what I've done now is I've sanitized that input. So what I need to do now, hit test my code. What we're going to do from here, we're going to recompile the application. We're going to redeploy it back in, and that's all happening in the background. I can see that happening in real time, so I can see the servers restarting, the code is deploying. I look at my application log, see if I've injected some errors. Like I said, this is the live code we're working with here. So it is entirely possible that I've actually injected more vulnerabilities or I've broken the application in some way by trying to fix it. So we do two checks. And as you can see here, my application is working, but it's showing that I'm still vulnerable. Vulnerabilities like cross-site scripting and SQL injection never happen in isolation. If you've made that kind of mistake once, you're probably going to find it in other places. So we jump back to our code editor, and if we look further down, we can see there's another section here, and again we can see that same kind of thing. So I've got this input that's coming direct from the end user that is being stored in a database and then being echoed out into the browser. So all I'm going to do here is exactly the same thing as I did before. So I'm going to use that cout tag, which wraps this and takes away those injectable components. And again, this is a built-in feature of this this library we're using. And I'm just going to remove the old ones. This one wants to be item.description. And then clean the old one out. And again, from there, I can go back into the preview mode. I can check whether the vulnerability is still there or not. For now, from my code editor, I'm going to look through again. So I had two locations, one on line 24 with the item title, and then again with the description. So I've wrapped both of those in the cout tag. And what that does is, like I said, just takes all of those malicious capabilities away. So any tags that were there are going to be encoded as HTML rather than actually rendered as HTML. So, assuming I've done this correctly, this time when I hit test my code, going to run through those same steps again. So it's going to take my code, it's going to recompile it, it's then going to pass it over to the deployment server. The deployment server is going to deploy this, and with any luck, we should see that this one completes successfully. And there we go, we can see my application is working and the application is now classed as secure. And lucky for me, I get a nice 100 points for doing so. So that's a really kind of simple example of how we can take something like cross-site scripting, put it in front of your developers, show them not just how those come to be, but the actual impact they can have, showing them all the way through that journey. So if you understand how an attacker can abuse a capability, then it's more likely that your developers are going to be in a better place to actually go and fix them. So like I said, it's all about shifting left and as far left as we can go. So when we talk about vulnerabilities, there are the obvious ones. So we've got the OWASP top 10, which changes every few years. So SQL injection, cross-site scripting, they're really easy things to find. And we recently published our CWP report, which looks at some examples. So we put it in front of tens of thousands of developers. We had tens of thousands of exercises run, and it was really interesting. So when you look at a developer's point of view, for the OWASP top 10, they're doing pretty well with like 82 to 90% completions across a wide range of them. So developers understand these fundamentals, and credit to any SaaS scanners out there, they're pretty good at detecting these. SQL injection, cross-site scripting, command injection, there are familiar patterns that we know we can search for. Where it all starts to go a little bit south is when we move away from traditional vulnerabilities and into things like business logic flaws, when we start talking about cryptography and some deeper complex situations where there's no actual vulnerability, there's no bad code. What you have is you have bad flows of data, where a developer might not understand that exposing all of that data over a GraphQL endpoint can be seen by anybody, even if you're not rendering it into the browser. So you'll see that if you look at all of our exercises across all of our application security tools, we don't just focus on the OWASP top 10. We look at all of those things. So we look at business logic flaws and how you can protect against them. We look at data flows. We look at fundamentals. So when you're talking about account and authorization flows, some of the hardest things to do securely when you've got to take passwords and credentials, especially if you're tying in with multi-factor authentication or third-party auth providers, then making sure you've got secure flows all the way through that can be difficult. And again, we're not talking about a vulnerability there. There's nothing broken. The developer's not necessarily written bad code. It just means those flows of data might not be as secure as you think. So we go into details in things like TLS fundamentals, cryptography, and cover those same kind of skills. So that's for you developers. Obviously, if you're from a management perspective, we have a full set of reporting and all that as well. So you can assign these out as exercises. We have customers who do things like create a set of objectives for their languages, whether it's Rails for the back end and JavaScript for the front end, like React, and they actually tie them together and say, you're not allowed to commit code unless you can actively demonstrate that you understand how these vulnerabilities get in, and more importantly, that you can fix them and resolve them afterwards. So that reporting, that metrics, that understanding of those human capabilities you have across your developers, they all start to play a role. And reporting, as much as I hate looking at graphs and I prefer to stay in the code, there is a place for that, and understanding how your teams work is important. So let's have a look. So like I said, we've got Java, we've got Python. I'm going to put myself on the spot now. I've not done this lab before, so I'm just going to grab one. So vulnerable libraries. This is a big thing at the minute. So over the last year, we've seen a big shift by attackers into supply chain compromise. And again, if you think about this, this isn't a vulnerability your developers have introduced into your application. This is you relying on third-party suppliers and third-party libraries. And if we just look back over the last several months, there have some big incidents where attackers have managed to compromise NPM libraries and replace them with malicious code. We also have actual developers, the actual owners of those open source platforms, self-sabotaging. So there are two instances. So there was a developer who didn't like that the code he released for free was being used by large organizations. And I can understand where he sits on that, but he released the code open source. He didn't like it, so he modified that library. Now everybody who depended on that suddenly had it installed, and all of a sudden it was misbehaving. So we had the actual developers doing that. There was a developer who took a political stance on what was happening in Ukraine and Russia, and decided that he would use his library to share a message of peace, not war. I completely get the sentiment behind that, but what I don't want is I don't want untrusted code suddenly appearing in my production environments. So again, like, these are the things we kind of have to worry about when we're looking at developers. It's not just the code they're writing, it's the code that other people are writing and bringing in as well. So at Immersive Labs, we cover all of those ranges as well. So in this lab, you can see we've got a vulnerable library. So if I start this one up, it's going to act much the same. So we're going to explain what these libraries are, how they can become vulnerable, how you can protect against how you can protect yourselves against them, the kind of impacts they can have, the mitigations you have, and again some examples of where we've seen this used. This one is Apache Struts, which isn't the same kind of supply chain compromise, but it was a third-party application which you've used in your world. And obviously the biggest one of these that we've seen, Log4j, I don't think anybody's going to forget that anytime soon. So that really kicked this whole world, and we have buzzwords like SBOM being thrown around and like software bill of materials. So we cover all those concepts. It's really important that you understand that when we talk about application development, it's not just your developers. And actually, if I step out of this for a second, when we talk about applications, most people think of those web apps you build, you deploy them through a pipeline, either to a physical server or into maybe a virtual Docker container. But one of the things we miss is that a lot of cloud applications now allow us to run things like Lambdas, like AWS run Lambdas. You can build an entire web application as a Lambda script, either in Node or Python or Rails. Now those typically don't go through the same deployment processes, through the same SAS scanners that we have for more traditional applications. So if we jump across to our cloud security offering, while these are mainly focused at cloud security engineers, the same kind of techniques apply. So whether you're a developer developing applications to run on thick clients or web applications, or a cloud security engineer deploying Lambda code, it's still vulnerable code that could be running. So we need to make sure we understand how all that works as well. So jumping into these kind of environments, we'll start to see more of those things happening. So whether you're desktop, thick client, or Lambda applications, like, it's all secure code, and we need the developers to understand the risks and how to fix them before. That's everything from me. So thank you for tuning in. And if you're around this afternoon, we'll be jumping into another crisis sim. We'll be handing out a McLaren Lego to one lucky winner, and there we're going to go through a we're going to run through an insider threat facing a pharmaceutical. Thank you very much.